Hi, everyone. It's crazy to think that this is probably our second to last unit before the end of the year. This unit is all about operations with radicals, which are just these square roots. So we'll learn how to add, subtract, multiply, divide, and simplify. So today we are just going to do the very basics of simplifying a square root, okay? So let's get started. Also, how fancy are these note packets? My goodness. All right. So it says the nth root of a number a can be written as the radical expression, the nth root of a. Okay. So some things we need to talk about. This little number here, that n, we call that the index. Okay. So that tells us, are we taking the square root of something, the cubed root, the fourth root, the fifth root, and so on. So this is just a little number, and that's telling us what root we're taking. Okay. The big check mark, that square root, we call that the radical, or you could call it a root. Radical or root. And then the number that's under the radical, we call the radicand. The radicand. Sometimes, well, actually, what you're probably used to seeing is there's never a number here where your index is. So if there's not a number there, we assume that it's a 2. So that means we're taking the square root of that number. And that's something you guys have seen and done before. Okay. If a radical has more than one root, the radical sign indicates only the principal or positive root. We guys circle that. So what does that mean? Well, that means, so if I just do a little, if we took the square root of 4, that means what number times itself is 4? Well, we know that's 2 times 2. That equals 4. However, you could have a negative 2 times a negative 2, which is also 4. So really the answer to that question is 2 or negative 2. But for this unit, it's safe to say, unless there's a negative out in front, you just take the positive root, okay? That's what that means. So if there's more than one root, just take the positive one. Okay, now they want us to list our perfect squares. So this list will be very helpful for you. You will use this a lot this chapter. It's kind of like the meat and potatoes of our chapter. We're going to use these numbers all the time. So a perfect square, you guys, is like 4, right? Because what number times itself gives me 4. So we just start 1 times 1 is 1. So 1 is our first perfect square. The next one, 2 times 2 is 4. So 4 is a perfect square. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11, 121. Then our last one for our first 12, 12 times 12, 144. And just like a little note, you guys, you know why they're called perfect squares? If you were to give yourself a square, some things that you might know about a square is that all the sides are the same, right? So all your sides of a square are the same length. So if you had a side length of 2 and 2, the area of that square would be 4. So 4 is a perfect square, which is why we wrote it down, right? You guys see that, the connection? If you had side lengths of 3, 3, 3. 3 times 3 is 9. So 9 is a perfect square. You guys kind of making that connection? Okay. You'll learn more about that anyways next year in geometry. So let's do some perfect square roots, okay? So they want us to simplify these square roots. So it's easy, right? For some of them, like 16, 16's on our perfect square list. So what number times itself is 16? Well, it's 4. That one's pretty easy. But then we already jumped to some really goofy ones. Okay, so I'm going to zoom out a little bit so you guys can kind of see my calculator here. Okay, so if we do 2, I can't do anything with that 2 yet. So I'm just going to keep the 2 out front. But now what's the square root of 121? Well, that was our 11th square root, right? Now 2 times 11 is 22. Okay, again, 6 here. Can't do anything with the 6 up front, so I'm going to leave it. Now I'm going to multiply. Well, 289, is that a perfect square? I don't know. So if you guys don't know, you just take your calculator. You're going to use a lot of your calculator a lot, in this chapter. So we're going to figure it out. So to take the square root of a number, you're going to hit second and then the x squared button. So now do you guys see how you have the radical symbol? And then type in 289. So the square root of 289 is 17. That is a perfect square. So that's really nice. So now we just have to take 6 times 17. Well, 6 times 17 is 102. And same thing with this next one. Can't do anything with that 3, so just write the 3 again. When they're right next to each other, you multiply. Now, is 400 a perfect square? I don't know. Let's find out. So again, hit the second button, x squared, and then 400. We get 20. So the square root of 400 is 20. 3 times 20 is 60. Okay, so those ones are pretty straightforward, right? Not a lot to think about there. But now we're going to get into some non-perfect square roots, okay? So I'm just actually going to list my perfect square roots along this side here. So that's going to help me in just a second. So maybe you guys should join me in doing this and rewrite these all right here so we can see them. I'm going to actually, that's okay. We'll stop there. Okay. All right. So let's see how we do these. So it says, step 1, find the largest perfect square that the radicand is divisible by. Break down the radical using this number. So our job is we have to break down the square root of 32. We have to figure out which one of our perfect squares evenly goes into 32. So this is my process. What I like to do, let's take 32 and divide it by 2. And we got lucky this time. It's 16. So look, you guys see how 16 is already a perfect square? That's huge. That's great. So we're just going to rewrite 32 in a different way. I'm going to rewrite it as the square root of 16 times the square root of 2. Okay, so we rewrote it. Now just take the square root of the perfect square. Well, 16 is our perfect square. So now what is the square root of 16? It's 4. So I took out the square root. And now do you guys see how 2 is not a perfect square? If I type in the square root of 2 in my calculator, it's some gross decimal. I can't break it down anymore. That's as small as it goes. So we just leave that attached to the 4. That's our leftover. There's nothing we can do. Okay, so let's do some more. But the big key here, you guys, is I want you to underline this in your notes. It says find the largest perfect square. You want it to be the biggest one on our list that fits into the original problem. Okay? All right, let's do number 6. So again, for number 6, let's start off by dividing by 180, or 180 divided by 2. So I get 90. So 90, I notice, isn't a perfect square. However, 90 would fall right here, right, between 100 and 81. So now I'm just going to play guess and check. I'm going to do 180, and I'll pick the next number below 90. It's 81. Does it go in there evenly? Nope, I got a decimal. Now I'm going to try 64. So 180 divided by 64. Still got a decimal. Try 49. Do you guys see I'm just going straight down the line? Nope, still didn't work. Trying 36. Hey, I got a whole number. That's great. So now we're going to rewrite the square root of 180 as the square root of 36, because that's what went in there. It's our perfect square. And how many times did it go in there? 5. So all we did again was rewrite the square root of 180 as a square root of 36 times the square root of 5. And now we can break it down. Okay, what is the square root of 36? That's our perfect square, and we know it's 6. The square root of 5 isn't a perfect square, so we just attach it. And there we go. 6 root 5. Okay, let's try 147. Again, 147 divided by 2. 73.5. Well, clearly that's not on our perfect square list. So now I'm going to go where 73.5 would fall. It'd fall between 81 and 64. So I'm going to try 64. So 147 divided by 64. Decimal. 147 divided by 49. Ooh, a whole number. Good day. All right. So again, we're going to rewrite it as a square root of 49 because that's our perfect square. And it went in there 3 times. So now we can take the square root of 49, which is 7 times root 3, because I can't break that down. Perfect. All right, let's try 175. Again, 175 divided by 2 is 87.5. Again, that's not on our perfect square list, but it falls between 100 and 81. So now let's start with 81. So 175 divided by 81, decimal. 175 divided by 64, a decimal. 175 divided by 49, a decimal. And just keep going, you guys. It's just guess and check. 36, also got a decimal. Okay, up to 25. Ooh, finally got a whole number. So now we can rewrite it. So the perfect square that went in there was 25. How many times did it go in there? 7. All right. So square root of 25 is 5. 7 is not a perfect square, so we just leave it. So 5 root 7. Okay, why don't you guys pause the video and try number 9. Same process. See which perfect square evenly goes into here. So start by dividing it by 2. Okay, I'm going to do it now. I hope you tried it, and let's see if we get the same answer. Oops. So I divide it by 2, and I get 24. So now I'm just going to try the next one, which is 16. And that was a pretty easy one. It was the first one we tried, right? So I have 16. How many times did it go in there? 3 times. The square root of 16 is 4 times root 3. Okay, now this last one's a little goofy because we have this number out in front. So what you need to do is forget about the number in front for now. So just rewrite it. Just put the 2 down there. Now the process is the same. Let's figure out what perfect square goes into 54. So again, take 54 divided by 2. We get 27. 27 is not on our list, but it's between 36 and 25. So let's try 25. So 54 divided by 25 is a decimal, so that doesn't work. 54 divided by 16. Ooh, another decimal. Let's try number 9. 9 was a good answer. So again, we're going to rewrite the square root of 54 as a square root of 9 times the square root of 6. Again, we can't do anything with that 2, so we're going to drop it down. The square root of 9 is 3, so we're going to put a multiplication sign between the 2 and the 3 because that's what this really means. And we don't know what the square root of 6 is. Or it's a decimal, it's not a perfect square. Now to finish this problem off, we just multiply. 2 times 3 is 6. So our final answer would be 6 root 6. Okay, how'd that go? Kind of weird? Kind of nice? Because now we're going to try the same thing, but we're going to take it to the next level and introduce some variables. So flip it over. Let's try some square roots with variables, okay, you guys? So I'm again just going to really quickly write down our perfect square list here. Okay. All right, so these are a little goofier. It kind of follows the same rules that we were just doing, but again, it's a little goofier. So we're going to now have variables, if you guys notice in our examples, okay? So we have 2 rules we need to follow. If m, so the power that your variable is raised to, is a multiple of 2 or an even number, why don't you guys write that? We use the following rule. You just take m divided by 2. Okay? We'll talk about that in a second and what that means. If m is not a multiple of 2, meaning it's an odd number, we break it apart. So if this is an odd number, we make it even, and then we have a leftover 1, because that's what we do. We take m minus 1, so we end up with an even number, and then we have 1a left over, which would be like to the first power. Okay? We'll talk about what this means. It's kind of goofy at first, but I think you guys will get the hang of it. Okay, so this first one, we have the square root of x squared. So let's decide, is 2 even or odd? It's even, so we follow this rule, m divided by 2. Okay, so 2 divided by 2 is 1, right? So x to the first power, or x, would be our answer. Because what you're trying to think of, you guys, is how many x to the powers of 2 can I take out of this? So I'll try another one here, okay? Just let that kind of simmer for a second. I know this is kind of goofy. Okay, our next one here. The square root of 9 times k to the 10th power. So we're just going to break it down into pieces. So I'm the square root of 9 times the square root of k to the 10th power. We know that the square root of 9 is 3. So that gets to come out of the radical. Now is 10 even or odd? It's even, so I just divide it by 2. So how many 2's can I pull out of there? 10 divided by 2 is 5. So we'll have k to the 5th. Okay, let's try another one. N to the power of 5. Okay, let's decide, is 5 even or odd? It's odd, so we have to break it down. So what do we do first? We're going to take 5 minus 1. 5 minus 1 is 4 times n to the first power. So now it looks like this, you guys. That's what we just did. We took 5 minus 1 to get 4, and then we have our leftover first power of n. Now we can follow the first rule. If it's a multiple of 2, so if it's even, we can just divide the number by 2. Okay? So now this becomes, how many times does 2 go into 4? Twice. So it's going to be n squared with the leftover n inside. Okay, let's try another one. So we're going to break it apart. And the square root of 40 times a to the 19th. Okay, we got to look. Is 40 on our perfect square list? Nope. So now we're doing what we were doing on that last page. The square root of 40. Oops, I lied. 40 divided by 2 is 20. 20 is not a perfect square, so where does it fall? It falls between 16 and 25. So let's try 16. 40 divided by 16, 2.5. 40 divided by 9, a decimal. 40 divided by 4 is 10. So now we can rewrite the square root of 40 as the square root of 4 times the square root of 10. Okay, now we got to figure out this a business. Is 19 even or odd? It's odd, so now we break it down. 19 minus 1 is 18, with 1 left over. Now we can break apart this whole long expression. The square root of 4 is 2. The square root of 10 is just 10. Can't do anything with it. What's 18 divided by 2? It's 9, so we have a to the 9th with an a. Now this is a really gross looking answer, so to clean it up, this is what we do, you guys. We put the stuff on the outside together, so it's going to be 2a to the 9th, and the stuff on the inside goes together, 10 times a. Woo! That was a pretty big brain energy problem. Let's try another one. So first step, break everything apart. We're going to have the square root of 25 times x to the 6th times y to the 13th. Okay, let's see. Is 25 on our perfect square list? Yep, because 5 times 5 is 25. So I can write that down. X to the 6th, it's even. So all we do is divide by 2. 6 divided by 2 is 3. Now we got to break apart this y to the 13th because it's odd. So 13 minus 1 is 12 times our leftover y. And we got to take it one step further, right? Drop down the stuff in front. 5x cubed. What's 12 divided by 2? 6. With our leftover y inside the radical. Yes, this is a lot. It's very involved. Okay, let's try another one. All right, break it apart. P to the 15th times Q to the 9th times just an R. Okay, 15 is odd, so we got to rewrite it. Divide minus 1. So we'll have P to the 14th times root P. 9 is also odd. So we have Q to the 8th times just a Q times our radical of R. So we broke everything down, and now we'll take it piece by piece. So since this is even, we just divide by 2. So we'll have P to the 7th on the outside times root P. 8 is even, so we divide it by 2. Q to the 4th, that's a 4, you guys, sorry, times a Q inside. Can't do anything with that R. Just want to write that all nice and neat. Stuff on the outside goes together. P7Q4, big radical, our single P, our single Q, and our R. Okay, we'll do 2 more. All right, let's do these next 2. So we got to break down 63. Is 63 a perfect square? It's not on our list, so we got to find out where 63 divided by 2 is. 31.5. So that falls between 25 and 36. So now from here, let's just try it out. 63 divided by 25, decimal. 63 divided by 16, decimal. 63 divided by 9, a whole number of 7. So we're going to break that down as the square root of 9 times the square root of 7 times b squared. All right. Now from here, we break it down. Square root of 9 is 3. Root 7 can't be touched. Can't do anything with it. Now b squared, what's the square root of b squared? It's just a b, right? Because divide 2 by 1. 2 by 2 and we get 1, excuse me. So now to make it look nice, put our stuff on the outside of our radicals together. So 3b root 7. Okay, you guys try this one, and then we'll compare answers. Go. Okay, let's see if we got the same thing. All right, 27 is not on our perfect square list, so I'm going to divide it by 2. I get 13.5, so that falls between 16 and 9. So I'm going to take 27, divide it by 9, and I'm going to get 3. So it's going to be root 9 times root 3 times n to the 3rd. Now we're going to break it down piece by piece. What's the square root of 9? We know that's 3, so I take it out of the radical. Root 3 is not a perfect square. And now this isn't even, right? So we have to make it even. Subtract it by 1 to get 2 with our leftover n. Then from here, we can break out this n squared, because what's 2 divided by 2? 1, right? So I have 3 root 3 times our n, root n. Then to finish it up, Put the guys on the outside together, so 3n, and our guys on the inside together, root 3n. I know this is a long one. Thank you for watching, and we'll see you later.